We're going to be covering 4.3 and I hope 4.4 today. So you can see your learning objectives and the major definition that we're going to be starting with. Okay. So example 414 says using the definition of the partial derivative as a limit to calculate the following for the function. So if I need to, I will duplicate the page, but hopefully we can get it all in one. I don't know if we will. It's a lot of writing, so I'm just going to try to duplicate it. I'll do it on the computer. Give me 1 second. You guys can look at it for the moment. There we go. Okay. All right, so we're gonna do basically we'll say that this is A and this is B. So for part A, the first thing we want to do is we want to calculate f of x plus h comma y. Hopefully we'll have enough room for everything. So that's going to be x plus h squared minus 3x plus h y plus 2y squared minus 4x plus h plus 5y minus 12. And if you go through and bring everything together, you're going to end up with x squared plus 2xh plus h squared minus 3xy minus 3hy plus 2y squared minus 4x minus 4h plus 5y minus 12. Okay, so the next thing we want to do is substitute everything into equation 412 and then simplify. So we're using so the limit as h approaches 0. And I will write it out this time. Okay, now we gotta try to put all this in here. Okay, so x squared plus 2xh. If you guys see like an easier way that you can organize this and you get the same answer, go for it. These can be very long. Okay, minus Right. Okay, so let's figure out what's going to cancel. Our x squareds will cancel. Our 3xy will cancel. Our 4x will cancel. 5y will cancel. 12 will cancel. All right, then that all makes sense, right? Because everything left has an h in it. So 2xh plus h squared minus 3hy minus 4h all over h. Right? Then we'll have the limit as h goes to 0. We'll get rid of some h's. And we have 2x plus h minus 3y minus 4. So then that tells us that our answer here is going to be 2x minus 3y minus 4. Okay. All right. So whether you're working with the 412 or the 413, you're going to want to do the little part first. So we'll do that with part B next. Okay. Yep. Hopefully everybody's good with that. So again, this part we did as A, this part we'll do as B. So part B. Before we do anything, we want to find now f of x, y plus h. So we'll have our x squared minus 3x y plus h plus 2y plus h squared minus 4x plus 5y plus h minus 12. And now we want to go through and simplify. Squared minus 3xy minus 3xh plus we would have 2y squared plus 4yh plus 2h squared minus 4x plus 5y plus 5h minus 12. Okay, and now we're going to use equation 413. So we're going to have over y, and that's going to be the limit as h approaches 0 of fxy plus h minus fxy all over h. So the limit as h approaches 0, x squared minus 3xy minus 3xh is 2y squared plus 4yh plus 2h squared minus 4x plus 5y plus 5h minus 12 minus x squared minus 3xy plus 2y squared minus 4x plus 5y minus 12. Okay, so x squareds cancel, 3xy's cancel, 2y squared cancels, 4x cancels, 5y cancels, 12's cancel. Cool. All right, so now we have oops. It's a K. Okay. They definitely have, but you have to find y plus h. They're not yk, but I don't really think in the grand scheme of things it super duper matters as long as you know what you're getting rid of. Okay. All right, so minus 3xk plus 4yk plus 2k squared plus 5k all over k. Yeah. Then we're going to get rid of a value k. So our answer here is going to be negative 3x plus 4y plus 5. Okay. All right. Okay, so for the next one, it tells you which way they want to what they want to define. So part A, so for the first one, we want to treat y as a constant. Isn't that just what we were working with? Yep. Okay. So I think what they're going to end up showing us here is that they're going to be the same answer. We're just going to take a different approach with it. So first we'll do it this way. And then we just have to break everything apart. Okay. So, then we're looking at 2x minus 3y plus 0 minus 4 plus 0 minus 0. So that ends up being 2x minus 3y minus 4. And that is the same as what we found earlier. Okay, we're going to prove the same thing with part B in a minute. I'm going to try this yellow. You guys can thumbs down and if you want me to never use it again. But hopefully it'll be okay. If not, we'll change it. I think that looks okay, but let me know if you don't like it. Oh, that's not really part B. Well, that is. I didn't finish part A. Let me squeeze it in here. I'm gonna try to just like do it a little bit more condensed. If you guys need to break it up the way we just did, you can. But I don't have a lot of room. So yeah. All right. Okay. All right. I'm gonna go with a different color choice then. All right, so we're gonna treat the y variable as a constant, and then we will differentiate with respect to x using the chain rule and the power rule. So all right, so we're gonna end up with the cosine of x squared y minus 2x plus 4. And then so if we bring that out front, we'll end up with 2xy minus 2 cosine of x squared y minus 2x plus 4. All right, that is the first part. And then now we have to do it with respect to y. So g with respect to y. So we're going to end up with, again, cosine And then we're gonna end up with just x squared in the front. Okay. All right, so this was just some notes that I thought were kind of beneficial. You can see them in the textbook, but you will also have them on the PDF of this. You don't have to worry about writing it down right now. So for this example, it says use a contour map to estimate the partial differentiation at the point square root of 5, 0 for the following function. So there's a graph that represents the contour map. The inner circle on the contour map corresponds to c equals 2. And then the next one corresponds to c equals 1. So I'm going to show you what it looks like. And hope that we have enough room to work with it. So basically you would set the equations equal to the c's in order to like kind of get an idea of all of that. So can try to match up the colors here. I think green would be the first one. So that would be 2 equal to the square root of 9 minus x squared minus y squared. And then we have a red, which would be 1. And then a blue, which would be 0. So c equal to 3 is just the origin. All right, so the first equation simplifies to x squared plus y squared equals 5. So the second one is x squared plus y squared equals 8. Sorry. All right. The x-intercept of our first circle, what color was that? Green. X-intercept is equal to the square root of 5, 0. The second one is square root of 2, 2 square root of 2, 0. All right. So now that we have this background information, what we're going to work on is our estimate. So going to find it's going to be from the square root of 5 to 0. So then we have And that ends up working out to be 2 minus 1 over square root of 5 minus 2 square root of 2. Which is, I'm going to skip the second step. So, okay. All right, now we want to go with respect to, so that was plugging in. Now what we want to do is the whole function. So and then that's going to give us okay, and now we want to evaluate that. And we should find that it should be pretty close. So let's, I guess, do it in yellow. Okay, so we would have negative square root of 5 over square root of 9 minus square root of 5 squared minus 0 squared. That works out to negative square root of 5 over square root of 4. And make this smaller. So this is equal to roughly negative 1.118. Right? So the estimate for the partial derivative corresponds to the slope of the secant line through the points square root of 5. I don't know where to show this. And no. Okay. It represents an approximation of the slope of the tangent line. I am running out of colors and space. Okay, so I think this one's this one, and this one is approximation to slope of tangent line to the surface point. Uh, Okay. Which is parallel to the x-axis. Parallel to x-axis. That was a lot for that. Limits, I think they take up a lot. All right, here's some more definitions. Okay, let's go with the next one. All right, so we want to calculate partial derivatives for a function of 3 variables. Use the limit definition of partial derivatives to calculate the following function. Then find with respect to, so we want to do with respect to x, y, and z by setting the other 2 variables constant and differentiating accordingly. So this is a longer problem. And okay. It looks like we're gonna do the long way for the first one and then the shorter way for the next 2. So we should be able to get it all on here. Let's try it. Okay, that's what I thought. All right, so we are going to do it with the longer approach for the with respect to x. If you want to do it with the shorter approach, like whatever approach works best for you, I'm fine with. So we would get x squared plus 2x h plus h squared minus 3x y minus. Okay. All right. I forgot the limit. That's so much to squeeze in there and forgot that part. All right. Okay, let's see what cancels. X squared, 3xy, 2y squared. Did I drop a z out? I dropped a z. I'm assuming at this point, is everyone okay if I also get rid of my h's now? We okay to combine those two steps? I think so, yeah. Cool. Okay. So that leaves us with the limit as h approaches 0 for 2x plus h minus 3y minus 4z minus 12. And if we throw the 0 in, then we're just going to end up with 2x minus 3y minus 4z minus 12. Okay. That is the long way. I could squeeze in the other ones, but I think instead what I'm going to do is duplicate this slide and I'll put the shorter ones on the next slide. Seems like a smart play. Did it not add? It did. There it is. Okay. We're just gonna get rid of it. You guys can definitely work on it as I do. I'm sure you might even be a little more than likely quicker than me because you don't have to write on this. Okay. The other thing I'm gonna do is I'm just gonna go straight to splitting it. I'm not going to do the extra step if you're okay with that. And there's even more. Okay. So that's going to leave us with 0 minus 3x plus 4y minus 0 plus 5x. Nope, 5z squared. Minus 0 plus 4 minus 0. So that's going to work out to be just minus 3x plus 4y plus 5z squared plus 4. So if you went through and did that with the other approach, you should end up with the same answer. Because we just proved that a couple slides ago. All right. You may get to the point where you might be able to do like a lot of this in your head. I'm not really sure. I would recommend still writing it all down just to be safe. You obviously wouldn't want to make a silly mistake because you did it all in your head. But to each their own. I will want work for your exam. Try not to be as lazy as I am. I'm definitely just like throwing in whatever random, very lazy bracket in there. Okay. So that should leave you with a 0, minus 0, plus 0, minus 4z. Nope, 4x. 4x plus 10 yz minus 0 plus 0 minus 3. Getting rid of your zeros, you have minus 4x plus 10 yz minus 3. Those of you that take notes, I hope you have a ton of paper. This stuff is getting long. All right. Part A. In each case, we treat all variables as constant except for the one whose partial derivative you are calculating. So let's look at part A. Okay, so we have f of x, y, and z. I don't need to rewrite that. We're gonna need the space, so. All right, so we're going with x first. X squared, y minus 4 xz plus y squared over x minus 3 yz. Okay. All right. This is crazy long. I don't even know if we're gonna have enough room on this slide for part A. Wow. Okay. All right, so let's work on combining the top. So we get 2x squared y minus 6xy squared z minus 4xz plus 12yz squared minus plus minus. And then some things can cancel. Maybe. At least one thing can cancel, right? Yeah. And then we can take away this. So we end up with x squared y minus 6x y squared z plus 12y z squared minus y squared. Okay. I have to get us, well, probably many more slides. So while I'm doing that, you guys can start on attempting to do this from the y, focusing on the y. So we need one for the y. We need one for the z. For the z. Yeah. All right. Okay. All right, so we're gonna approach this now from the y. If you're already working on it, you can keep working. All right. So here we would have minus 4x. Nope. That's for the next one. We're gonna have x squared minus plus 2y. The x cubed is 3x. Negative 12. Negative positive. Okay. So for those that aren't working, what can we get rid of? This and this. This gets rid of 3 of these. I think that's it. So here we have x cubed plus 2xy minus 3y squared z minus 12x z squared over x minus 3y z squared. Okay. All right. Let's get this. I'm hoping for the second one we only need the one slide, but we'll see. All right. Let's do this last one here from the Z perspective. We end up with minus 4x 3yz. Oops. Three squared y squared negative. Okay. And we get rid of anything at 12. That's it. Okay. I'm going to do my best to squeeze part B into one. We might have to get one more slide. I really hope not, because we're kind of running out of slides. All right, so from the, this is for part B. From the X perspective, sine so that's going to lead us to oops. Yep, wrote that part wrong. Okay, so that leaves us with okay. Now let's go from the y. All right, so you guys can see that the detail wasn't as deep in the second part. I'm hoping we can get into the next section at least halfway. And then as long as we hit halfway, then I'll be good. Pull this. And all right. Oh, it's just an extra slide now. Yeah. Okay. All right, so calculate all four second partial derivatives for the function. Bro. Okay, we can do this. Such a gross problem. All right, so yes, Seth, I agree. I think all of you, if you do your homework, you should be fine, but the actually writing of all this is pretty rough.
No, change your sheets.
Okay. Okay, so for the next one, we need this first. Actually, that one's. I think what we're gonna do is we have one more obnoxiously long problem, and then we'll go as far as we can into the next lesson until my hand cramps, which is already getting pretty close, and then we'll pick up from there next time. All right, so we have some concepts here. And like I said, this is also in your textbook, and when you get the PDF of this, it'll be a little bit easier to read too. So first we want to calculate this UTT. Why is that not what we're supposed to write? Because I think they have us. Apologies. Apparently we didn't need that step. Here's where it changes. Hey. Come on now. Okay. All right. Last step for this one is negative 500 pi squared sine. Okay. So that becomes all right, and let's try to squeeze this. We have 2 more sections, or 2 more spots. So I'm actually gonna add another slide. If anybody wants to try, you can try to find the U double Y. I guess we'll call it U sub double Y. And you can update. Thank you. Okay. Almost done for the day. And then that becomes -80. Sorry. Okay. All right, then the last step, now that you have all of that, and this will verify your solution, you're gonna do 4u xx plus uyy. Okay. Okay. That was a lot. That was a lot of writing. I hope 4.5 is not nearly as long, or else I don't know how we're gonna get through it. I might have to maybe record some stuff offline, I don't know. But we will start the next one. Let me share this as a jam. Okay. And 4.4. All right, so this one claims to only be 10 slides long. However, we've been writing our hands off, so we'll see how far we get. I don't know. I mean, ideally, I wanted to get the whole way through it, but we'll see. We do have half an hour. So this is 4.4, which is tangent planes and linear approximations. You can see your learning objectives. You have a definition here. I gave you a really nice fancy graphic from the textbook. There's actually 2 definitions. Okay. All right. So finding a tangent plane. Find the equation of the tangent plane to the surface defined by the following function. And this is why we just did everything, because we want to kind of use those concepts. And now surprisingly, it's much less writing, I guess, because they figure you've had to do it for a little bit. So the derivative, partial derivative from the x direction from the y and then we also have to plug in our values. Are you guys okay if I just put down the answer for this? You guys should be good, right? So that would give you 34. And then f of xy or 2, -1 would give you 13. And from the y direction, it would be -26. Okay, so what that all tells us is the following. Using equation 4.24, we get z equals f sub 0 y sub 0 plus f of x sub 0 y sub 0 plus or times x minus x sub 0 plus f of y, f sub y. So we're just gonna plug everything in. 34 plus 13 x minus 2 plus negative 26 y minus a negative 1. So that works out to 34 plus 13x thank God, minus 26 minus 26y minus 26. Okay. And we're going to get rid of this so you guys can see this a little bit better. All right. Okay. Let's try to power through this. Just give me 1 second. I just need to send a phone number to someone real quick. Okay. Let's try to power through this, and then we'll just have to do 4.5 on Thursday. I know it's a lot of writing. At least you guys know I'm writing it with you. All right, so finding another tangent plane. Find the equation of the tangent plane to the surface defined by the function. So first, you guys we want to calculate from our partials. And then we want to plug in our initial values for each. You guys can write it out. I'm just going to kind of shorten it so that we have a little bit less that we're writing. Okay, then using all right, so then we get C equal to and if we make everything nice, we get okay. All right, we have a definition. Okay, almost done. All right, using a tangent plane approximation, given the function, approximate using the following points. What is the approximate value to 4 decimal places? So we're going to use equation 425. All right, if we do f of x sub 0, y sub 0, if you plug everything in, you're going to end up with the square root of 16, which is 4. So if we plug everything here, we get -2. And if we plug everything here, we get -3/4. All right, so now we want to substitute into the equation. And that equals 3.875. There's one more spot that we have to do. So now we're going to do f of 2.1, 2.9. You plug it in, you're going to end up with the square root of 14.95, which approximately is 8.8665, which is a 0.2% error in approximation. Right? Which is not that bad, I don't think. Okay. Here's another definition for everybody. You guys are doing great today. We're nearly done. We have two more examples, and then I'll stop the recordings and you guys can ask me any questions you might have, and then we'll be done. All right, demonstrating differentiability. Show the function is differentiable at the following point. So the first thing we want to do is we want to calculate f of 2, -3, which if you plug it in, it's going to give you 20 from the x side. So you would just have 4 times 2, which is 8. And from the y, you would just have -4. Okay, so that means that our first slope is 8 and our second slope is -4. So what do we do with that? We are going to f of xy So 2x² minus 4y equal to 20 plus 8 plus, again, -4. Oh, and now we have to do the limit. It's okay, we're almost done. We can do it. Two x squared minus 8x plus 8 over the square root of x minus 2 squared plus y plus 3 squared. Oh, we're gonna do pull a 2 out, we get x squared minus 4x plus 4 over a square root of x minus 2 squared plus y plus 3 squared. Then I'm gonna write down the next. Oh, I see. Okay. I see what they're doing. Then we will say this. So our limit is 0. Okay. Since, here's what you need in writing. Since e x sub y greater than or equal to 0 for any value for any x or y, the original limit must be equal to 0. Therefore, f of x, f of xy, sorry, equal to 2x squared minus 4y is differentiable, spell it the right way, at point 2, -3. Oh, thank goodness. So very close to being done. All right. We're going to go a little bit quicker. There's some theorems for you and a definition that you're going to want to get off of the PowerPoint. Make sure you read it and get it. And then there's another one you have to use probably in the next section. So get that as well. Let's wrap up with this last problem. Okay. So first we need to know and if you plug that in, you're going to get 33. Then you need from the x direction, which would be 6x minus 2y. From the y direction, actually those are not those are just x and y. Minus 2x plus 2y. And then if you plug it in for this one, you get 18. If you plug it in for this one, you get -10. Now we're going to substitute into use equation 4.27. And we get dz equal to f of x, x sub 0, y sub 0, dx plus f of y, x sub 0, y sub 0, dy. So you get 18 times 0.1 minus 10 times negative 0.05. And if you work that out, you get 2.3. This is the approximation to delta z and you find that by doing f of x sub 0 plus delta x comma y sub 0 plus delta y minus f of x sub 0 y sub 0. So when you fill it in, you get f2 plus 0.1 minus 3 minus 5 f of 2 -3. So f of 2.1 and if you work that out, then you get 2.3425. Okay,